Part 4, covalent bonding, sp3, 4 bonding locations, all middle energy. They all form sigma bonds, very strong bonds. This is methane. It's tetrahedral, as we saw before. These are 4 sigma bonds. So here is that sp3 hybridization of the carbon, and you put a hydrogen in each of those 4 orbitals. This is a tetrahedral structure. It's a rather odd looking one, but it's tetrahedral. It's nonpolar. It is a molecule, nonpolar molecule, and you see the s orbital from each hydrogen, and then the sp3 is the blue. A further example, if you have ethane, where you have C2H6, there you see quite clearly the 4 sp3 hybridized orbitals for each carbon, and then a hydrogen on the end of 3 of them, and then the carbon-to-carbon bond is the 4th sp3 orbital, and so you have 4 for each carbon, and that's ethane. Here is ethene, sp2 with this pz, this higher energy p. And there you have the sp2 hybridization, a better illustration than I could do on the front board. You have the sp2, so you have the 4 red orbitals, the 4 red sp2 orbitals, and then you have that pz, that light blue cyan color, forming 1 bond. Looks like 2 bonds, but it's actually 1 bond. The orbitals are overlapping at the top node and the bottom node, and that's actually forming 1 bond. So you have sp2, where you have 3 sigma bonds, that's the red, and then that pi bond. Here are some additional illustrations for the pi bond, that overlapping of the pz orbital at the top and bottom node, forming this single pi bond. Remember, the pi bonds are weaker than the sigma bonds. Here is an additional example where you get this node above and below. It's a single pi bond. Here we have the sigma bond in the green, and then the single pi bond above and below, but it's actually 1 pi bond. We have 4 bonding locations, but we have the sp2, that middle level sp2, and then we have the higher energy p suborbital. And for sp, ethyne, we have sp, and then that middle energy, and then the higher energy py and pz. And here is ethyne, C2H2. You can clearly see the 2 sigma bonds. Remember, this is sp, so you have 2 sigma bonds. The carbon on the left, 1 sigma bond is to the hydrogen and 1 sigma bond is to the other carbon. And then the carbon on the right, 1 sigma bond is to the carbon and 1 sigma bond is to the hydrogen. And then you have 2 pi bonds. You have the blue and the yellow form 2 pi bonds. Let's call that the blue py and the yellow pz. And you can see that overlapping above and below. Here's another illustration where the py is the green and pz is the orange, forming 2 pi bonds.
where you have an overlapping of the node above and below. And here's two pi bonds. This is ethyne again. Both are green. It's not as clear here, but the sigma bonds are in red and the pi bonds are in green. Remember, the nodes above and below are overlapping. It looks like two bonds, but it's actually one bond. So each pi bond above and below, the two nodes above and below, overlap. So you have the Py and the Pz forming bonds, the node above and below. So the Py is the green, above and below. For each carbon, they're going to overlap, and you're going to form a pi bond. And the Pz in the orange will do the same thing. So between the two carbons, you have a sigma bond and two pi bonds. So that's a carbon-to-carbon triple bond.
We'll illustrate this when I load the video onto YouTube. Okay? That is hybridization, sp3, sp2, sp. You have the pi bond. There's a pi bond there. And then you have two pi bonds for ethyne. Okay? Easy? Okay.